So I got 3 problems today for optimization. First one here, number 7. A farmer wants to construct a rectangular pig pen using 200 foot of fencing. The pen will be built against an existing stone wall, so only 3 sides of fencing need to be constructed. What dimensions should the farmer use to construct a pen with the largest possible area? And we're going to do this with calculus. All right, we're going to have to optimize and show those formulas. So can everybody picture there is an extremely long stone wall in the world, right? Straight as an arrow. And we have to build a fence, all right, that looks like this. And our first thing is to have a great picture. And I think we all can see this picture. And then you have to introduce some notation on it. My notation is I like the verticals to be Y. I like the horizontals to be X. And I know one relationship about Y, Y, and X. 2Y plus X is going to be equal to 200. I have 200 foot of fencing. That's what's going on. That is my constraining equation. That's my limiting thing, right? What do I, area is X times Y. And everybody, here's what we got to stop and pause. This is what I want to maximize. I want to make A big. And then our first instinct on optimization problems has to be look at this and say, uh-oh, SpaghettiOs, there are 2 variables. We can only optimize when we can write the function in terms of 1. So I have to get this area equation in terms of 1 variable. The easiest way to do it this time is to move the 2y to the other side. All right? And now you can write an area equation that is solely based on, in this case, y. Now, everybody, on your calculator, right at this point, we could graph this. We could change y could be the x-axis, right? Change that y to x. And area could be the y-axis. It's a parabola that's upside down, and the maximum area, right? If I graph this function on an a versus, I hate that you put the y and the x, so we'll say, but area versus the vertical length, which I'll call y. Guys, this picture is going to be, something like this. All right? And we know that the maximum area is going to be right there at the vertex of that parabola. I mean, so you can find this answer pretty easy. That said, I want to do it by calculus. I don't want to do pre-calculus. All right? So I have that. I need to move this stuff over out of the dead spot. So I'm going to use that equation, all right? And I'm going to take the derivative of it. I'm going to say A prime. A prime is, I think it's 200 minus 4y. And I like this problem. I like problems that are, for grading purposes, this is an easy one to see. Could you set up constraints? Can you make the picture? Could you get the constraint and the area formula? And then did you know to get to a single variable? And now do you know to set the derivative to 0 because you're looking for a max? If it says draw the picture, you decide if you want the points. All right? Everybody, I get y is 50 feet. So guess what? It said, what dimensions? I think it's 50, 50, and that leaves, I think, 100 foot of fence in here. Now, everybody, what if I told you to justify this with the first derivative rule? How would you know this is a max with the first derivative rule? Okay, the derivative would go positive or negative. So here's what I would do. If I would say a prime of 49 was greater than 0, it's positive, right? A prime of 51 is less than 0. You could do that by plugging in the values, but I know this is the maximum, and I'm cheating, right? I know it goes from positive to negative on the first derivative, so that's the way I would do this, all right? I am not going to probably ask you to justify it, but the answer is 50 by 50 by 100. which points on the graph of y equals 6 minus x squared are closest to the point 0, 3. Does everybody see this is a this is a flip parabola shifted up 6. It's y equals negative x squared plus 6. So you don't need a graph. You don't need a graph. You don't need a graph. That said, I'm going to make a graph. 1, 2, 3, 4, 5, 6. Everybody, there's our parabola. Closest to point 3, 0. Boom. Now, everybody, your instinct might say it's 3, right? 3 to 6. But almost for sure, it's going to be right here, right? Some distance. This problem is a little more difficult, all right? Because we're going to have to optimize the distance. We want to know which point is closest. So, I do know the point on the axis. That is 0, 3. That's easy. Do I know what point is going to be closest on the parabola yet? No. So I'm going to call that point in blue xy. And every time I've been doing these problems, I think I've been pretty consistent, all right, with using the same notation. Because at this point now, for you guys who memorize the distance formula, it is that, you know.
Jared Hansen and Lorelei Padgett, would you please stop by the office before you leave today? Jared Hansen and Lorelei Padgett, would you please stop by the office before you leave today? Thank you.
All right. I got it back. All right. So now, that distance between 0, 3, and xy, if it helps, I like making points and showing the triangle for students so we kind of see that this is just the Pythagorean theorem, right? And every time I do this, the distance formula works the same, right? The distance here is x minus 0, which is just x. And that's one of the nice problems because it's on the axes. This distance here, this time, is just y minus 3. And this distance, little d, is the distance between the points. That's what we want to optimize. And everybody, when you can draw this right triangle of this situation right in there, all right, I can write d squared equals x minus 0. I'm going to write that as x squared, guys, plus y minus 3 squared. All right? Now, everybody, you can optimize d. You take the square root through the chain rule. But we also know that if we minimize d, we also minimize d squared. And also, this is the big trick when we've been practicing these. Every time we want to minimize distance between 2 points, we always say, hey, let's ignore the square root, right? Because it doesn't affect. If you minimize the number, you minimize the square. If 2 is your smallest number, 4 is your smallest square. You can't get 3.8. So it works the same. But again, I make this equation right here. So here we are. Write the equation. There it is. But the problem now is I have to optimize it, and it has 2 variables. But again, we are given some information about where the point lies. And everybody, I don't want to use y. Well, do I? I don't think I want to use y. Does everybody see you can solve that for x squared pretty easy? So my temptation right now is to write this as x squared equals 6 minus y. You guys agree? Boom, other sides. And that's going to make this derivative a little easier when we're done. So I can say the distance here is 6 minus y plus y minus 3 quantity squared. And everybody, if I take d prime of this now, I get negative 1 for negative y. The derivative of 6 is 0, right? And then I'll use the chain rule. 2 times 2 from the power comes down times y minus 3 doesn't change. And the derivative of the inside is just 1. So when I'm all done doing d prime, I'm going to write it down here and pull it up. D prime equals negative 1 plus 2y minus 6. So I think d prime, when I simplify completely, it's just 2y minus 7. All right? So guess what? I have now found, all right, I have now found that. And again, we always optimize the same way. Set d prime equal to 0. And everybody, this is a visual one. Does everybody see y has to be 7/2? Now there are a bunch of ways to get x. You could go back and, I think the easiest way to get x is just to go back and use the original equation. So it wants the point closest. We know the y value is 7/2, so I just have to plug in 7/2. 6 minus 7/2 is 5/2. Square root of 5/2. Ugh. It's ugly, all right? And it'll be both. It'll be plus or minus, won't it? Because when you plug in y and you take the square root to solve for x, right, it will be plus or minus. All right? And again, that's more pre-calculus. So when you do that work, you should get, they left? All right, x squared equals 6 minus 7/2. X squared is 5/2. So it's plus or minus the square root of 5/2. Comma 7/2. That's the point closest. Makes sense, one on each side. All right, keep practicing. We'll do the other one tomorrow.